We are currently in an age of automation. In this environment, protecting in-house know-how and creating cheaper homemade automation are essential measures for each company, even in terms of human resource development. In response to this, Mr. Nakamura recruited people who used to work on-site who were interested in automated equipment, and for a certain period of time, he promoted improvement activities that focused on the creation of automated machines. As a result, he has been able to realize effective automation of handmade automation at low cost and by integrating on-site know-how. In this article, I will introduce the main points of the book and examples of implementation. In the early 2000s, when Japan was in a recession amid a climate where expensive IoT products were being sold, Eisen Company Limited introduced the handmade automation shown in the figure below. This automated guided vehicle was an automated machine that effectively used springs and gears by utilizing the weight of the products in the process of processing automotive parts, but it was a device that did not use electricity at all. The idea for this device was based on the mechanism of karakuri dolls, which were popular in the Edo period, and since then, this type of automation has been actively taken up in the industrial world. Several years before Eisen Company Limited's automatic transport machine was introduced, Mr. Nakamura had been instructing project teams that made various kinds of inexpensive automated machines, with on-site workers working on handmade automation as full-time improvement teams for a certain period of time. This type of automation was not the method shown on the left side of the diagram, where the machine was manufactured in consultation with an external automation specialist company, but rather the method shown on the right side of the diagram. The characteristic of this method was that it was a method of automating part or the entire process by assembling inexpensive parts in a DIY manner while thoroughly improving the work procedures performed by workers. Therefore, it was a method that not only solved the problems that the method on the left side had, but also realized extremely inexpensive automation that made use of on-site know-how. At this time I will introduce this method. The LCA, i.e., low-cost automation procedures and measures introduced here, do not necessarily mean complete automation. Even if fully automated, it still requires human labor to manage the automated machines. Therefore, we based the method on promoting low-cost automation within the procedures performed by humans to the extent that they can be automated. First, we perform video analysis of human work and proceed with i.e. process analysis and ECRS improvement. In this case, as shown from the left to the right of this photo, we first analyze the current situation with pantomime, and then use wood and cardboard to thoroughly improve the work and automate the work that can be automated, along with the work analysis based on the current situation analysis. Now, I will introduce the contents of the work analysis in this LCA procedure. Here, we will use the process of cutting metal pipes, whose thickness and length are fixed at 6 cases, with a grindstone cutter, and the process of removing burrs from the cut end of the pipe with a file after cutting. First, when performing the current work, we will reproduce the work using the pantomime method. At the same time, we will write down the work steps using nouns and verbs. This is the current situation understanding shown in the figure. Each task performed by a person has its own purpose. Therefore, when analyzing the tasks are described using nouns and verbs. After that, although the details are written in a book, a functional tree diagram like the one shown here is created by clarifying the purpose of each card, the tasks performed in the form of higher-level and lower-level purposes, and the use of tools. Once the diagram above is completed, as you can see, the purpose of this task will be twofold: to cut the pipe to a fixed length, and to remove the burrs that occur on both ends of the cut pipe when the material is cut. If the optimal countermeasures are put together, the main point of automation will be the automatic machine elements. After that, if the configuration is made as inexpensive as possible, It will become an automatic cutting equipment without burrs. Note that automatic material input and output equipment is not included in this consideration. Therefore, measures will be added as necessary. So far, I have explained the basic ideas of this book and how to proceed with low-cost automation. If you plan to use this method in practice, I recommend that you understand the more practical steps shown in this figure. Please refer to the book for details about these steps, and I would like to introduce an example of this application procedure. However, in factory production, low-cost automation is only one way to improve human work, not the whole purpose. In this diagram, the left side of the dashed line means that, as a result of analyzing the work, those that are not suitable for automation are excluded from the low-cost automation measures. This case was a countermeasure requested by a company, in which a robot would recognize the shape of the casting, which changes each time, and use a cutting tool to remove the burrs. Robots are expensive, and the cutting edge of the blade used to remove the hard burrs easily deteriorates. More than 10 project teams have attempted to robotize this in the past, but they had all failed. Moreover, the robots were expensive and sturdy. So, the project team that Mr. Nakamura was involved in, which took on this theme, applied a method called work design, and completed a countermeasure from the perspective that, if the casting does not have burrs, there is no need for a robot to grind the burrs. Several examples of this type of countermeasure are included in the book, so readers should refer to them. The success of low-cost automation depends on the quality of the idea. For this reason, we use VE, as shown in the figure. This method involves asking 7 questions to clarify the functions of the target object and work procedure, and then using all information to generate analysis and ideas for the best solution. It is simple and practical for those on the manufacturing floor to use without having to learn specialized VE, so it is effective when pursuing low-cost automation solutions. This example shows the task of feeding round steel pieces, sometimes up to 4 m long, into a centerless grinder one by one. It is a tough task of arranging the materials, which have become covered in oil from the previous process, on a sloping platform. Many engineers have attempted to solve this problem, but have failed to do so. The on-site improvement team, which Mr. Nakamura is involved with, has been tasked with automating this task. The task analysis and task function analysis shown in the figure are analyses conducted by the project team. This diagram shows the results of our research and idea generation to come up with a way to automatically line up long bar materials. There are many machines on the market for automatically lining up short bar materials, but none of them are applicable. Therefore, we not only looked for patents, but also went around hardware stores and other places to thoroughly research and generate ideas over a period of 3 weeks. We also put together ideas that were highly effective, and while checking the ideas for automatic lining with a handmade automatic machine, we sought out the most promising method. The left side of the figure shows an automatic bar alignment system that was actually installed on-site, based on a full-scale steel-framed experimental machine that was created. Furthermore, although there were only about 10 of these machines, it was necessary to make them into a series and add more. Therefore, technical experts pooled their ideas for the equipment on the right, and have the price and size. At this manufacturing site, this equipment had been expected to be a dream machine, and it has been a brilliant realization of that dream. Thank you very much for watching the introduction to this Kindle book. The above explanation is the gist of this picture book. You can also get it at this URL. Amazon Prime members can watch it for free.